Think of that moment when you look up at the sky on a clear night, far from the city lights. Billions, perhaps countless, of those points of light that shine like needle points. Stars, those silent witnesses that have guided humanity for thousands of years, inspired legends, used to read the future, and reminded us how big the universe is and how small we are. So how is it that these celestial bodies, millions of light years away, can emit such bright, powerful light? What makes them shine? The secret of a star's shining is the story of nuclear fusion, the most powerful and creative force in the universe, that is, the merging of atoms to create new elements and enormous energy. For our ancestors, stars were the eyes of the gods, holes open to the heavens, and the immortal souls of heroes and gods in the sky. Constellations such as the Great Bear, Orion, the Hunter, and Andromeda were used to draw mythological stories and heroes in the sky. Astrologers believed that the positions of stars affected human destiny. Philosophers debated whether they were other worlds like Earth or diamonds set in the sky. For a long time it was thought that stars, like the sun, shone by burning something like coal or wood, but this idea was wrong. If the sun were made of coal, it would burn out in just a few thousand years, but it has been shining for billions of years. The energy source that makes it shine must be much more basic and much more powerful. A star's birth begins in vast cold clouds of gas and dust, nebulae in space. These clouds are mostly made of hydrogen, the simplest and most abundant element in the universe. Over millions of years, gravity slowly begins to pull the pieces of this cloud together. As mass gathers, the pressure and temperature at the center of the cloud increase. In this process, a core called a protostar, which shines but is not yet a true star, is formed. As the protostar continues to swallow the gas and dust around it, its mass, and therefore the pressure and temperature at its center, continues to increase. Eventually, when the temperature at its center reaches about 15 million degrees Celsius, a critical threshold is reached. Under this incredible heat and pressure, the nuclei of the hydrogen atoms overcome the electromagnetic force that normally repel each other and are forced to combine with each other. 4 hydrogen nuclei, protons, go through a series of complex steps to form a helium nucleus. This process is called nuclear fusion. And here is the real miracle. The mass of a helium nucleus that forms is slightly less than the total mass of the 4 hydrogen nuclei that formed it. So what happened to that lost mass? This is where Albert Einstein's famous equation E equals mc squared comes into play. That lost mass has not disappeared, it has been converted into a tremendous amount of energy. This energy emerges in the form of photons, particles of light, and neutrinos. Every second, about 600 million tons of hydrogen in the core of our sun is converted into helium, and in the process, about 4 million tons of mass are converted into energy. This is the energy equivalent of millions of hydrogen bombs exploding every second. This is what makes stars shine, these nuclear fusion reactions that continue unabated in their cores. These reactions bring 2 giant forces into balance. While gravity tries to crush and collapse the star inward, the outward thermal pressure created by fusion resists this collapse. A star spends most of its life in a delicate balance between these 2 forces, in other words, in hydrostatic balance. As long as this balance continues, the star continues to shine steadily. It can take hundreds of thousands of years for a photon born in the core of a star to reach the surface. At the end of this long journey, it is released from the surface into space and begins a journey that can last millions or even billions of years. That flickering point of light you see in the night sky is a photon that set off from that star millions of years before you were born and has finally reached your eye at the end of a long journey. So when you look at a star, don't just see a bright dot. See a giant nuclear furnace where the brutal force of gravity and the creative fire of nuclear fusion dance in perfect balance, transforming the universe's most basic elements into heavier ones. Each star is a forge where the building blocks of the universe are forged, a shining hope illuminating the cosmic darkness.
to Knowledge, presented by Toyer TV. Don't forget to take your place on this path of discovery and enlightenment.